Today we are going to see quick sort in the data structures. We will see how quick sort works, and after that we will see different applications, and then we will see the example, and then we will do the implementation of quick sort algorithm in Python. And at the end we will see the complexity analysis of quick sort. Okay, hello everyone, this is Sharda from GoEduHub Technologies, and I would like to welcome you for this session. Can you please confirm me in the chat window, am I audible clear and loud? Okay guys, so let me start now. First of all, we will see, like in the last class we have seen two sorting algorithms, a very basic sorting algorithm. One of them is bubble sort. Everybody knows what is the bubble sort and how does bubble sort works. And second algorithm is we have seen insertion sort, right? So we know how the insertion sort works. Now we will see the quick sort. Basically quick sort is very important and it is quick. Like in this sorting, we basically do very fast sorting. Just give me 1 minute. Okay guys? And just think about it. What is the quick sort and how does it work? Just I'm plugging in. Sorry for disturbance. And now we will see what is the quick sort. Okay, so first thing comes to mind is this is the divide and conquer algorithm. Okay, let me write here divide and conquer. How does it works? Like what we will do in this algorithm and how we will sort the data with the help of quick sort. Okay? There are the different algorithms in which we divide our data into different parts. After that, we separately work on those parts and then combine those parts. Okay? So it basically picks a pivot element. We will select the pivot element, or you can call it a key element. Okay, and then we will divide the data. We do the partition of the list or array according to that pivot element. Like in the left side of pivot element, all the elements should be lesser than this. Like here is a pivot element, suppose. Okay, and in the left side of this, all the elements are less than this pivot, and right side of all the elements are greater than this pivot element. Okay, here the thing comes to mind is how we choose the pivot element. Okay, mainly key process here is partition. We divide our given array into two parts. Okay, and in two parts on the basis of pivot elements. And we got the correct position of our pivot element in the sorted array and then put all the smaller elements into one part. I will take the example, don't worry about it. How we choose this pivot element? Because if you study this algorithm over the internet, you will find there are the different ways. Some people are doing, they are picking the pivot element, first element as a pivot element. Some are picking last element as a pivot element. And some are picking the random element as a pivot element. And some are picking median as a pivot element. So there are the different ways. Like we can pick the first element, okay, and we can pick the last element, and then we can pick the random element, okay, and we can pick the median value. Okay. Are you getting the things? Okay. Basically, this quick short algorithm is quick. Why its name is quick? Okay. Fact is that this is capable sorting a list of elements fast other than different other algorithms. It is generally twice and thrice faster than the other algorithms. Or you can say this is most efficient algorithm. Okay. What we will do here, we will pick a pivot element, okay, and then splitting our array into two parts. One is smaller part and one is larger part. Okay, I'll tell you the steps how we will do the things. Okay, so here I'll write certain steps how we are going to do the implementation. Okay, steps, here steps I'm writing. First thing, we will select a pivot element. So select and this is little bit complicated, you will understand. I'll tell you in very easy manner. We will take an example so that will clear your every doubt. Okay, we will select a pivot element. Okay, and then we will do the partition the array on the basis of this element. And then what we will do, recursively we will apply quick sort on the left partition as well as on the right partition. So apply quick sort on left partition and apply quick sort on right partition. Now we will see how we can do the quick sort, how we can apply the quick sort. This is the simple quick sort, follows the steps. Then there are the different rules for this quick sort algorithm. Okay, so let me take an example here. Are you getting the things, guys? Can you please confirm me in the chat window so that we can go ahead? Okay. Now I'll pick an example here. I'll pick a list, or you can say an array. Okay, a unsorted array. Unsorted array, I'm taking here 5 and then some value 3, 8, 1, 4, 6, 2 and 7. Okay, here I have 8 elements. Okay, and before going towards this example, I'll tell you the steps for the quick sort. Like we have seen the steps for the quick sort inside this step number 3 and step number 4, in which we apply the quick sort over the left part and right part. How we will apply this quick sort? Okay, here the pivot element, the condition for the pivot element is in the left side array and right side. in the left side, all the values are smaller. And in the right side, all the values are larger. Okay? Here, what we will do in the step 1, we will pick first element as a pivot element. Like this element. Okay? And then we will define two variables for traversing this array. You can say I or j, you can say low and high, you can say start and end, whatever you can call. Okay? I'll define two variables. Okay? I can call it start and end. Or I can call it I or j. Or this is the first element, this should be the first element, and this should be the last element. Okay? And then what we will do, we need to ensure like in the left side of this pivot element, all the elements should be lesser than this. So we increment I, increment this start. Okay? Until, like what we will do here, we will check this is my pivot element. Initially pivot element and start is same, so there is no comparison. For the second element, this is the pivot element and this is my start. Okay, my start is less than the pivot element. Okay, then I'll increment start by 1. Start will become here. Okay, so we will increment the start until our list element, list of start is greater than pivot. Like whenever you will get an element that is the greater than this pivot element, like suppose here we are coming to the 8. So 8 is greater than 5. So we will stop here. And we need to shift this. Okay? And second thing is, parallelly, here we have started the start. And here we have started the end. Two variables. So end we are moving this side, like end we are decrementing. Okay? And start we are incrementing. So end we will decrement until list of end okay, list of end is less than pivot. Because this side we want the elements greater than pivot and this side we want the element less than the pivot. Okay? And then in the next step, we will swap. What we will swap? If start is less than end, okay, then we exchange. I'm writing the rules, then I'll show you one example. Okay, in that example we will follow these rules. We swap list of start. Don't worry if you are not getting the properly, I'll tell you one more time. List of end. And otherwise, okay, we will exchange the pivot element with the list of j element. Exchange, or you can say swap pivot and list of end. Okay, I'll open the next. I'll don't close these rules. Okay, and I'll repeat these steps until we will having the condition of start less than the end, and I'll open one more. Then we will follow these rules. Okay, I'm keeping these rules. And now I'll take an example. Okay, so same example I'm picking here. Values like 5, then you can say 3, then you can say 8, you can say 1, and then 4, 6, 2, and 7. Okay, this is my list. And inside this list, my pivot is 0. Index you can say 0, 1, 2, 3, 4, 5, 6, and 7. My pivot is 0, this element. The first element is pivot element. What happened? Okay. This first element is pivot element. So pivot I am picking here 0, and you can say left, right, or you can say start, end, whatever you want. Start I am picking here 1, and end I am picking here 7. Okay. This end means size minus 1. Okay. Now what we will do? We will compare pivot. We will start from this side. We will go from this side. Okay. And we will go from this side, both sides. Okay. First we will compare. My pivot is greater than the 3. Okay. So we will increment the start by 1, because we want in the left side, in the start side, we want the less element which are lesser than this. Actually what we want to shift this 5 at its correct position. And what is the correct position for the 5? You can say correct position for the 5 is it should be after 3, 1 and 2. Like it should be something like this: 3, 1, 2 and 5. 5 should be here. Okay, and other elements here, and like elements in the left side should be 3, 1, 2, and elements in the right side is remaining elements. So we want the correct position, this 5. So for putting the 5 in the correct position, what we need? We need elements which are less than this should be in the left side, and elements which are greater than this should be in the right side. Okay. So we will compare the start element, list of start element. Okay. And whenever we are getting the element which is greater than this pivot element, then we will stop our start. So in the first case, our start is here. I'll change one more color. Okay. My start is here. My pivot is here. Okay. And my stop is here. I'll increment, because this element is less than this pivot, so I'll increment the start. My start becomes now here. Okay. I'll increment the start. And then this 8 is greater than the pivot. That is 5. So I'll stop the start here. So now my start is here. Meanwhile, I'll check the condition for a stop also. So for the stop, the 7 is greater than 5. Okay, that is good. So I'll decrement the stop by 1. So stop comes here. Okay. Now 2. 2 is not greater than this. No. So we will stop here. Now our stop is at this position. Okay. And our start is at this position. Okay. I'll make one more array. And this, in this array, 5, 3, 8, 1, 4, 6, 2 and 7. Now my stop is here and my start is here. and here is my pivot element. Now I'll check one condition. If start is less than the stop, okay? If start is less than the stop, then we will swap them. Okay? So what we will do, we will swap 8 and 2. One condition is start is less than stop, swap list of start and list of stop. Second condition can be like my stop is less than the start. That time what I will do, I will swap pivot with L of stop. This is the condition. Okay, and I'll got the index of pivot and divide index of pivot. I'll return and divide the array into two parts. Divide the list. Okay, so here what happens? 2 comes here and 8 comes here. Okay, after this again I'll compare. My start is here, my start is less than 5, okay, 2 is less than 5, that is correct, so I'll increment the start by 1. 1 is also less than 5, okay, so I'll increment the start by 1. Now my start becomes here. Okay, and this is also less than 5, okay, so my start comes here at 6th position. Okay, and meanwhile I'll check for this, and this 6 is not less than the 5, so I'll stop the start here. Now what I will do, I will check for stop also. So for the stop, 8 is greater than 5, 8 is greater than 5, that is the correct. Okay, so I'll decrement the stop by here. 6 is greater than 5, that is also correct. So I'll decrement the stop 1 here, and 4 is greater than 5. No. So my stop comes here. Okay. Stop is at 4 and my start is at 6. Okay. Let me change the color. It's a little bit confusion. Okay, stop is here, here is stop, and here is start. Now you can check, start is greater than stop, and the second condition becomes true. So what we can do, we can swap pivot element with the stop element. So pivot element is 5, and we will swap 5 and 4. Okay. So now the new array becomes, here 4 comes, then 3, and then 2, then 1, and then 5, okay, and then 6, then 8, and then 7. Okay, and my pivot is swapped now. So I can see, I have observed all the numbers to the left side of the 5. Okay, I can see here all the numbers in the left side of the 5 is lesser values. Okay, and all the values in the right side of the 5 is greater values. And now 5 is at its correct position. Okay, we will return the index of 5. So we can say we can return the index of stop. Okay, we can return the index of stop. And we divide this into two parts. One is from start to this index of stop I'm storing inside the variable pi. Okay, so start and then pi minus 1, and second part is pi plus 1 and then stop. 2 array becomes, and we will recursively apply this quick sort on both the arrays. Okay, getting, guys? I hope you got the things. Now come to the steps again. What the steps I have written previously. Like here, first we need to pick the pivot element. Then we are picking the two variables. One is the start and another is end, or you can call it a stop. Okay, then what we will doing, increment the start until we found an element that is the greater than the pivot. Okay, and in the fourth step is decrement the stop, or you can say end, until we will found an element that is the less than the pivot. Okay, and then if our start is less than the end, then we swap start and stop element. And if start is greater than the end, the sixth step, start is greater than the end, then we will swap pivot and list end element, and we return the index of end element, and we will partition our array into 2 parts. Okay, I hope all these things are clear. Okay, we will do further. Okay, this is our array. Okay, just keep an eye on this. 4 3 2 1 5 6 8 7. This is my new array. Okay, I'll pick this array and divide this array into 2 parts, and separately I'll apply the quick sort. Okay, so here I'll write this 4 3 2 1 5 and then 6 8 and then 7. Now I have done with this element. This got its correct position. Okay, okay, and in the left side of this 5 we have all the elements smaller than this pivot, this 5 value. Okay, and in the right side is all the elements are greater than this pivot element. Again we will apply quick sort here over this list and over this list. So in this list we will pick the pivot. Here we will pick the pivot 4. This is my pivot, and this is my start, and this is my stop. And for this also, this is my pivot, this is my start, and this is my stop. Okay, so in the left sublist you can see here the element, this is 4, 3 is less than this, 2 is less than this, 1 is less than this. Okay, so now my new start will go, it will traverse, and there is no element that is greater than this. Okay, let me change the color. Okay, and for the stop, you can see for the stop is basically first element is less than this 4. So our stop is here and our start is also here. what we will do? Both are at the same position, we will swap them. Okay? When both are same, you can say start equals to stop. In that condition, same case we will apply, like for the equal and for start is greater than. Okay, we will swap pivot and L of stop. So here we will swap 1, 3, 2 and 4. Okay? And now you can see our pivot comes at its correct position. Whenever you will swap the pivot, it means we are doing here the partition. So it means 4 is at its correct position and 5 is already at its correct position. Okay? And its left list is 1, 3, 2 and there is no element in the right side of 4. Okay? So we will apply again on 1, 3, 2. And similarly for the 6, 8, 7, this is the pivot element. Okay? And for the start, we will compare 8 is greater than this. So start is stops here. And for the stop, this is greater than 6. So stop comes here. 8 is also greater than this. So stop comes here. Okay? So we will swap here pivot and you can say start and stop. Okay? You can say here stop is here and start is here. So my stop is greater than a start. So we swap pivot with the right. Something wrong went. What I have done here? Sorry, this is my pivot element, okay? And this is my start element, 8 is, and 7 is my stop element. Okay? And you can see my start stops here. Okay? And my stop is also come to here. Both are at the same position. Okay. Stop is also here. It won't go till the pivot. Okay. Both having at the equal position. So we will swap pivot with the stop. So what we will write here? We will write here 8. It should be 6, 7, 8. Actually, this pivot is swaps by itself because this is the stop. Let me clear it again. 6, 8. Separately we will write it. Okay. This is our pivot and this is our start. Okay. and this is our stop. What happens here, first we will compare these two. Start remains here. Stop, this is correct, and then stop moves here. Okay? Stop moves here, this is also correct, this is also greater, so stop moves here. So stop comes here. And stop is greater than start, so what we can do? We can swap pivot with the stop. And pivot and stop both are the same, that is the 6. So 6 would remain here, and 8 and 7 is new array. 8 and 7 is new array. So this 6 got its position. And then this is my pivot element, and this is my start, and this is my stop. So for the start, this is less than, okay? And for the stop, this is also less than. So stop comes here. Okay? Stop comes here. Stop, don't move. Guys, are you awake? What I am telling you. Here, stop, don't move, because it is less than value. So stop is here, start is also here. So what we will do in the case of equality, we will swap stop and pivot. So we will swap 7 and 8. Okay? Similarly, we will do for 1, 3, 2. This is my pivot, this is my start, and this is my stop. Start remains here because this is greater than 1. Okay? And stop also remains here, and start is less than the stop. So we will swap 3 and 2. So 1, 3 and 2. Then again we will compare, start is greater and stop is less than. 2 and 3. Start is greater. So start remains here, stop comes here. Okay? And both are the same, we don't need to swap here. This one got its correct position, and we will divide from here. Okay guys? Actually, I'm just trying to tell you. Okay, one more time I'll explain you, don't worry. What I'm doing here, the first part you are getting, we have taken this 5 as a pivot element. One more time I'll explain you, don't worry about it. Some people are not getting the things. Let me write clearly. Okay, same example I'll pick again. And this time I'll tell you quickly. Five, 3, 1, sorry, it was not 1. 5, 3, 8, okay, and then 1, then 4, 6, 2, and 7. Initially, this is my pivot, P, and this is my start, okay, and this is my stop, okay. This is less than this start, that is correct. We will increment start by 1. So my new start becomes here. Okay, new start is here, and this is greater than 5, so start remains here. And now we will see the stop. Stop is greater than, then we will decrement stop by 1. This is not greater than, so stop remains here. In this case, start is greater than stop. Okay, so what we will do, we will swap start and stop. So here we will put 2, and here we will put 8. Okay, and position of start is this and stop is this. Now we will compare. 2 is less than 5. Okay, and 2 is less than 5, so we will increment the start by 1. 1 is less than 5, so we will increment the start by 1. 4 is less than 5, we will increment the start by 1. Now my start becomes here. 6 is less than 5, no. So now my final start remains here. Now we will see about the stop. 8 is greater than 5, yes, that is good. So we will decrement the stop by 1. 6 stop comes here. 6 is also greater than 5, so we will decrement by 1. Okay, now stop comes here because 4 is greater than 5, no. So now my final stop is here. Stop is here, okay, and start is here. Now start is greater than stop. Okay, when start is greater than stop, what we will do? We will swap pivot element with the stop element. So here we will swap 4 and 5, and our new array becomes 4, 3, 8, 1, 5. So here not 8, here is 2. 1, 5. Okay, 6, 8 and 7. This is my new array. And when your pivot is swapped, that time we will partition. So partition means this is left array and this is right array. Again same thing we have to apply over the left array and the right array. Okay, and now 5 got its correct position. Okay, so 5 is at its correct position, and we will see over 4, 3, 2, 1. We will apply 4, 4, 3, 2, 1. Four, 3, 2, 1. Okay, and 5 is at its correct position, and in the right side we have array that is the 6, 8 and 7. Now my pivot is here, P is here, start is here, and in place of a stop you can say end. Okay, end is here. Now we will apply here. First we will see in the left side you can see this start is 3 is less than the 4, right? So we will increment the start by 1. Start comes here. 2 is also less than 4, so we will increment start by 1. And 1 is also less than 4, so start comes here. Okay, now we will see end. We completed this list. We will see for the end. Okay, and end is basically 1 should be greater than 4, but it's not. So our stop end remains here. Okay, and when start and stop are equal, start and stop are equal, then what we can do? We can swap end element with the pivot element. So we will swap 1 and 4. So our new array becomes 1, 3, 2, 4. And now 4 got its correct position. And we are breaking in two arrays, sub arrays. This is left 1, 3, 2, and in right there is no sub array. So we are getting new sub arrays 1, 3, 2. And 5, it's already its correct position. Similar thing we will apply to this. This is P, this is start, or you can say this is stop. Okay, this start is should be 8 should be less than 6, no. So start remains here. For the stop, 7 should be greater than 6, yes. So we will decrement stop by 1, stop comes here. And this time also stop 8 is greater than 6, that is the correct. We will decrement stop by 1. So now my stop comes here. Okay, and when my stop and pivot at the same position, okay, stop and pivot is same position and start is not greater than this. Okay, here the stop is greater than start. That time we will swap pivot and stop. So pivot and stop are the same, 6. So 6 swap by itself and it got its correct position. And new array we are getting 8 and 7. Okay. Same thing we will apply for the 8, 7 and we will apply for 1, 3, 2. Now hope everything is clear. For 8, 7 what we will do? 8 and 7. My P is here and my start and stop both are here. Okay. What we will check? Pivot is, this is less than, start is 7 is less than 8. That is the correct. And this is not greater than, so stop comes here. If stop is not greater than, then stop always remains here. Right? So stop remains here and start also remains here. Start and stop are equal. In the case of this, pivot is 8 and 7 is less than this. So start remains here because there is no more elements, and for the stop 7 is should be greater than 8 but it's not. So stop remains here and start remains here. So start and stop are equal, then we will swap pivot with the stop. So 7 and 8. And 8 got its correct position. And this 7 is one element, so this is also at its correct position. So 7 and 8 here, 7 and 8. And similar thing we can apply for 1, 3, 2. Okay, this is pivot and this is a start and this is a stop. And pivot is, for the start, this is should be less than but it is not, so start remains here. And for the stop also, this should be greater, so this is greater, so stop we will reduce by 1. This time also stop is greater than, so we will, stop comes here, and what happens, 1 swap by 1 and this got its correct position. Then we got the new array 3, 2. And 3, 2, in the case of 3, 2, we will swap 2 and 3. Because pivot is 3 and then start and stop is 2. So we will swap stop with the pivot. So final it becomes 2 and 3. Now I think everything is clear. Now we can see the practical implementation, coding part. Okay? Let me open the Google Colab. Little bit tricky, but I'm repeating same steps. Whatever the steps I'm performing for the first time for the quick shot. Steps you need to remember. Simple steps. Okay? So here I need to write the different functions. And there are the 3 ways, like I can write code for this in the different ways. First thing, I'm writing here, like I'll pick the first element as a pivot element. You can pick the last element as a pivot element also. Okay, little bit difference in the logic, but both the ways are the correct. So here I'm defining the logic for the quick shot. Def, okay, I'm defining a function for quick shot. Quick shot. Okay. Inside the quick shot, what can I pass? I can pass elements Okay, and then I can pass start and I can pass end. Okay, and inside this I can write a condition. Okay, I need to traverse complete list. So if start less than end, okay, then what I can do here, I'll return the index of the partition. Partition, okay, and inside the partition I can write elements and then start and then end. This is one time I'm calling the partition function. And then I'll apply the quick sort on the left part and the right part. So quick sort, okay, elements start, and in the left part what would be pi minus 1. And same thing I'll apply quick sort for the right side. So elements pi plus 1 comma end. Okay, I need to apply this quick sort on the left part and right part recursively. And this function partition I'm calling to get the index of partition element, pivot element, where we are getting the partition of the array in the left part and right part. So let me define this function partition. Okay, def, how we can do the partition. Okay, inside the partition I can write the rules, elements, and then start and then end. Okay, and here I'll pick pivot element index, that is start point, start, and then pivot element is pivot equals to elements, okay, of pivot index. Okay, this is one thing. Now I need to write the loop here. While, okay, I'll write here while I need to traverse complete list. So start less than end. Okay, and inside this I need to write certain conditions. Two conditions. Either my pivot is greater than start or my end is greater than pivot. I need to increment the start and I need to decrement the end. Two loops I'm writing inside this. Okay, so while one condition is elements of start, okay, is less than equal pivot. Okay, and then what I can do, start equals to start plus 1, right? And one more loop I'll write here, while elements of end, okay, is greater than pivot. In this condition, what I can do, end equals to end minus 1. Okay, I'll decrement the end and here I'm incrementing the start until all the elements are less than the pivot and all the end elements are greater than the pivot. Two conditions I have written inside the loop because I need to traverse all the elements. Now here I'll write the condition, if start is less than end, then I'll swap. Which one I'll swap? I'll swap start and end. Okay? So I can write a function swap separately, and inside the swap I can pass start or end. Start, end, and then I can write elements. Okay? And this swap function I'll define. Okay, inside the swap function, what I am doing, I am swapping start and end. Otherwise, okay, if this condition is not true, means end is not greater than start. It may be possible start is greater than end or start equals to end. That case, we will swap pivot with the end element. So outside this condition, okay, or outside this loop, what we will do, we will swap pivot underscore index, okay, pivot index and end element from elements. And what we will return? We will return index of end element that I told you. Return end. Okay? And I'll define one more function, that is the swap. Def swap. And inside the swap, I'm writing a comma b comma array. And inside this, if a is not equals to b, it should be condition, otherwise what will swap? Okay, I'm taking a variable temp equals to array of a. Sorry, what happened? Array of a, okay, and array of a equals to array of b, and then array of b equals to temp. Okay, now I have written the swap function, okay, and written the partition, okay, and written the quick short. All three functions I have completed. Now I'll start the execution. Okay, so let me write here some elements. Elements equals to some values I'm picking. What the array values I have taken in the example, that is 5, 3, 8, 1, 4, 6, 2, 7. Okay, I'm taking this list. Okay, and then I'll call here quick short. Inside the quick short, I'll pass elements, okay, and then I'm passing here 0 initial start index, and end index I'm passing length of elements -1, okay, and then I'll print elements. Okay, let me run this code. Hopefully this will execute. Index out of range. Yes, I got an error. In pivot is greater than equals to start. Yes, here I need to write one more condition. What condition I have to write? Like sometimes what happen? I'll go outside this. So here I'll write one more condition, and okay, start should be less than length of elements. Okay, otherwise it will go out of bound. Now I'll run this. What happened? Index out of range, quick short elements 0, and it should execute. I don't think. Quick short elements 0, length of elements minus 1. Start is start should be less than this. This is a condition, I hope. Okay, let me check it out. Yes, now it's working. Because what happens, it will check first this condition. And if it will check this condition, then it will go out of bounds. So I need to write this condition first. Okay? And this is sorted array. Clear, guys? Are you getting the things? Quick short implementation we have completed. Let me tell you the complexity of the quick short. Now we can analyze the quick short. And where we can use the quick short. There are the different questions should comes into your mind. Okay? You can see here in the worst case complexity of quick short. Here we are using 2 loops. Okay? So in the worst case, it should be order of n square. Like what happens, this quick short calls n times. And recursively we will call n minus 1 times, n minus 2, and finally order of n square. When the worst case happens, when our data is already shorted. And in the best case, it is log of n into log of n. In the best case occurs when the partition are evenly balanced. Like always, your pivot element got the middle position. If we are having the shorted array, then what happens? It will divide. Let me write here. Okay. For the best case, okay? Like I have n elements. And I have n elements and n by 2 and n by 2. Partition always gets in the middle. Then n by 4 and n by 4. Similar for this. So you can say height of this tree is n of log of n. This is the best case. And in the worst case, what happens? Our data is already shorted. In the shorted, what happens? N and here 0 and here n minus 1. Then again 0 and then n minus 2. Again 0, n minus 3. Something like this. Finally, at the end, 2 and then 0 and then 1. So for this, if you calculate the time complexity, then that is the like n plus n minus 1 and then n minus 2, something like this. 1. So it should be order of n square. Okay? For the worst case, it is order of n square when list is already shorted. And for the best case, it is n log n. And for the average case also, complexity is average is also n log n. And sometimes some questions comes like quick short is in place algorithm or not. So what is the in place algorithm? In place algorithm means it will work, it don't need extra memory. All the numbers are sorted within the original array itself. So you can say quick sort is in place algorithm. Okay, and then when we will study the merge sort, then we can compare how quick sort is better than the merge sort, and like which one is faster. Obviously quick sort is faster. I told you initially quick sort is more faster. So generally we are using the quick sort when we need fast and efficient sorting. Okay? Some real-time applications like commercial computing and numerical computations, information search, for all these things we are using quick sort. Like we just want to sort out some data of accounts or profile of some person or some transaction sorting, then we always use the quick sort because it takes less time than the other algorithm. Okay? So what we have done, we have applied certain steps for the quick sort. We need to select a pivot element and then we are dividing the array into two parts. Okay? I hope what will be the space complexity for the quick sort. It's an order of n. Like it's not taking extra space. Okay? For the worst case, it's order of n. And for the best case, you can say log n. Okay guys? After the class, just try to implement this algorithm. Like you just want to select the pivot element, last element as a pivot element, and then write the code by yourself. Okay? I think this is enough for today. If you have any question, you can ask me. Otherwise, after the class, please complete your assignments. Okay? Thank you so much. We'll see you tomorrow. And we are having the regular classes. Okay? So we will complete in the next 15 days, we will complete this batch. Try to complete all the concepts of the DSA. Most important concepts.